Hello, I'm going to review problems. I'm using one of the versions, but basically all of the versions are the same procedures except the numbers are different. Problem number one has to convert 350 pounds put to Newton meters, and of course for all of these three problems you need to make sure you understand every manual because that's the only thing you'll have available to you. So let's work on this first problem. 350 pounds put. And the other thing to keep in mind is if you do watch these videos, you can stop, look in your handbook and find the information, pause it, and uh, make sure that you understand. I'm sorry, uh, this going back and forth. So then we have 1 Newton meter is 0.7376 pounds put. So this is like a one step. And so this equals 474 point. And then if you write everything here at this point, it's Newton meters, but then we use three significant figures. So we have 475 Newton meters. Problem number two, you have 600 pounds per cubic feet, and you want all of this in kilonewtons per cubic meters. So let's convert the pounds to kilonewtons and the cubic feet to cubic meters. So if you look at the handbook, the conversion is 4.48 newtons is 1 pound, and this converts it to newtons, but I want kilonewtons. So 1 kilonewton is 1,000 newtons, and so then we have the kilonewtons here, which is what I want, and now I'll convert the cubic feet to cubic meters, and I have 3.28 per meter, but these are cubed per cubic meter. So this is very, very important. Cube that because you so this is 94.85 kilonewtons per cubic meter, and it's three significant figures, 94.9. Remember to, if I provide you with that space, to write it there. The last problem, or the last part of this problem, you have 8 feet per hour, and you need to convert this to millimeters per second. So let's convert 1 hour to seconds, 3,600 seconds. So we have seconds here, and then 0.3048 meters per foot. And then of course, now we have meters, but we want millimeters, and you have 1,000 millimeters per meter, and this equals 0.6773 millimeters per second, and then three significant figures. That completes that part. Make sure you understand your FE review manual. Second part, the second problem has to do with calculating resultant forces. And before I start to discuss this, I want to point out a couple of things. We have here the resultant force, and many of you understood that to mean that was just adding the forces, F1 and F2, and that is not correct. Remember, in the book, the bold means vector. If it's not bold and it's italics, then it's magnitude. Okay, it's important that you understand that because whenever we talk about bold, then that means that it's the vector, so it can have a bar on top or the little arrow here. And this is what that means, not a scalar addition. So what this means is that when I look at the resultant forces, then I'm looking at vectors. So it would be F1xi plus F1yj. And then F2 would be F2 xi plus F2yj. And the summation of the two would be then my resultant force in x would be F1x plus F2xi plus F2x plus F2y plus F2yj. And so this here would be the resultant force. I hope you have understood that very well. So F1 here, sorry, F1 here is 235 pounds, and this is F1, and this here is 370 pounds, and this is F2, and this is the magnitude. But of course, you know, if it's a number, then that's what it is. So then this here is not bold, so it's asking for the magnitude of the resultant force, and the magnitude of the resultant force would be, using the Pythagorean theorem, would be the resultant force in x and the resultant force in y squared. Okay, so let's do this. So the resultant force in x, I do a summation of the forces in x. Always use this expression to show that then to the right is positive. Now, and as I said, you can pause all this. I'm going to erase this to then bring out another important point. Okay, so let me just erase this real quick. Remember, you can always pause it if you didn't catch it all. And because I want to show another very important point, and that is, in this case, you have, this is your y, and this is your F1, and this is your angle theta. So you can either do this projection here or there. Okay. So when I look at this angle here, if I look at the sine of theta, the sine of theta would be the opposite. And in this case, the opposite would be F1x. So F1x over F1. So that in this case, I'm using sine and I have the x. If I do the cosine of theta, would be F1, but then it's the adjacent, which is in the y, divided by F1. But if I look at the other vector, here I have my x, and here's F2, and here is my 45-degree angle. So if I look at my angle here, cosine of 45, which is the adjacent, would be F2x over F2, and my sine of 45 would be the opposite, which is y over F2. So the point I want to bring here is that you cannot make the assumption that sine would always be y or cosine x, because here you can see that sine here uses F1 and x, and here is F2y. So you have to look at which is the angle that is been given and make sure you understand that. So when I come to then do my calculation, I look at the 235 pounds and the projection in x would be with the sine of 30 degrees, and then it's positive, the other projection, the other force, 370 cosine of 45 degrees. So this is 379.1 pounds. This is my resultant force in X. So now the resultant force in Y, I look at the summation of the forces in Y, and I slightly point out the positive direction that I have, 235 cosine of 30, and then I have the minus, and then I have 370 of 45 degrees, and this equals negative 50.1 pounds. Okay, so let me continue here underneath, and very important is the fact that we'll have a sketch. Always do a sketch. Okay, always. That helps because then you have on X is 379.1 pounds, and I'm not scale, then in Y is negative 58.1 pounds. And here is the angle. So this is my resultant force. So when I'm going to calculate my resultant force using the Pythagorean theorem, then of course I have the square root of 379.1 squared plus 58.1 squared. And negative squared is a positive, so the magnitude is 384 pounds. So 384 goes. Now it's asking for the angle. It's important that you read the instructions because it's asking me measure twice from the positive x-axis. So measure counterclockwise from, starting from the positive x-axis. It's asking for this angle, which is called B here. I can calculate zeta if I just look at this triangle here without taking into account the signs, okay? I have this zeta. If I take into account the signs, then it'll give me like a minus negative zeta in clockwise direction, but I personally prefer just to look at my triangle, find the angle, and then answer the question that's asked. So, sorry. So I can do tangent of zeta is going to be equal to the opposite, which is the 58.1, and the adjacent, which is 379.1. So this angle theta is 8.71 degrees. But that's not what it's asking. It's asking for B, counterclockwise. So this angle would be 360 minus 8.71, which is 351. So I hope this helps. This completes part 1 of your resultant forces and unit conversions. There should be a part 2 and also a final part for your explanations for the exam. Hope this helps. Thank you.